Hello and welcome to our topic for today, and that is angiogenesis. 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 A very important topic that does not get the due justice that it deserves because angiogenesis is important from three parameters. The first parameter is healing. There is no healing without angiogenesis. And the second parameter is tumor progression in cancer. There is no tumor progression in cancer and uncontrollable cell division and tumor spread beyond the parameters and the constraints of the tumor and the violation of the contact inhibition that the cells usually obey, and these cancer cells are now able to extend beyond their parameters and beyond their contact and constraints. They need angiogenesis. And the third parameter is a compensatory mechanism, where in atherosclerosis in the coronary arteries, if they are obstructed and we have atherosclerosis, then we would the body would initiate, the tissue would initiate angiogenesis as a compensatory mechanism to make new blood vessels, new arteries, new on the side to escape from the sites of obstruction and be able to deliver and perform blood perfusion to the tissue. So let's talk about angiogenesis. What is angiogenesis? Angiogenesis is the sprouting, formation, and development of blood vessels from blood vessels. So we're not in embryology where blood vessels come from some crest, but here we have to have a blood vessel. From that blood vessel, we then move on to the creating the other blood vessels. So that's the very important criteria for you to understand what angiogenesis is. It's the making of blood vessels, the sprouting of blood vessels from other blood vessels. That's the first thing to understand. Then, why is it important? We talked about the first parameter, and that is healing. There is no healing without angiogenesis. And I know we talked about proliferation and how when there is a cell death, the neighboring cells would start to proliferate and cover for the cellular loss, these damaged cells that were removed in inflammation. And we talked about how tissue stem cells these progenitor cells would differentiate to make new cells. That could never happen without angiogenesis, without blood vessels that would bring blood supply to these proliferating cells. The blood supply is carrying oxygen, is carrying nutrients, and is also removing and washing off metabolic waste and toxins. So no proliferation without angiogenesis. In fact, angiogenesis comes before proliferation. And the proof for that is what we see in cancer. And that is, if cancer cells rely on the blood supply that they initially have, they can never go beyond their constraints. They can never invade, they can never become invasive. Okay, they can never migrate to distant sites. So they need extra power, so that means they need extra blood supply, they need extra oxygen, and they need extra nutrients, and they need extra sources of blood supply that would wash off the metabolic waste generated in metabolism. So angiogenesis is a core requisite, is a very important requisite for proliferation. So, and then we talk also in the third parameter in how, when it comes to atherosclerosis, these coronary arteries, the coronary arteries feed the heart muscle itself and provide that heart muscle with oxygen and nutrients, and also remove and wash out or wash off the metabolic waste and the toxins. When the patient is suffering from atherosclerosis, that means these coronary arteries, they are clogged and they are obstructed. So instead of 100% of the blood flowing through and perfusing 100% of the heart, now that obstruction would cause about only 60%, 40%, or maybe 30% of the blood to reach the destination. So what happens is a compensatory mechanism is initiated, and it's like a first aid uh, mechanism where angiogenesis would be initiated to go around these clogged, these these atherosclerotic plaques, these atherosclerotic um, arteries. Would make through angiogenesis new arteries that would go around the sites of obstruction to the tissues and be able to now deliver oxygen and nutrients and remove the metabolic waste by the blood circulation. Okay, what we need to know now is maybe you don't need to know for the USMLEs and for your class the details, the biochemical pathways and events that unfold, but you do need to know from a macrocosm, from a perspective, what really happens. So what do we have here? In angiogenesis, the process is not really understood in that depth, but what is known is that there is cell-to-cell communication. You know, the endothelium, they are cells. The endothelium, they're not just plastic tubes, they are cells. They respond to cytokines. Remember, in inflammation, we talked about how cytokines released from a site of injury or necrotic debris or trauma, they would send cytokines, and the nearby blood vessels, the endothelium in the nearby blood vessels, they would detect these cytokines and respond by performing retraction and creating interendothelial gaps. And through these gaps, macrophages would be able to leak out. These monocytes would differentiate into macrophages and new neutrophils. The polymorphonuclear cells would leak out, and these endothelial cells, they do respond to cytokines. So when it comes to angiogenesis, there are factors, okay? Vascular endothelial growth factors. We have platelet-derived growth factors. We have pathways like the Notch signaling pathway. These pathways drive the ability of the endothelial cells to sprout and start migrating and elongating and reaching out to nearby blood vessels to initiate this tunnel and the making of these new blood vessels. Okay, so what is believed happens is blood vessel would send angiogenic factors. These angiogenic factors would, first of all, what we have in blue, these are the pericytes. So the first step is the release of angiogenic factors. The angiogenic factors cause a separation between the pericytes. There was a detachment between the pericytes, and then we would see that there is nitric oxide. I'm sorry, this should have been a little wider. So the blood vessel receiving the angiogenic factors, they would receive nitric oxide and they would dilate. And they would also undergo, they would become more permeable. And then a leading tip, an endothelium, would start to respond to these vascular endothelial growth factors, and they would start to reach out to the nearby blood vessel. So the fourth step is, now we would have elongation and migration of the endothelium from both directions, and then we would have extracellular matrix deposition, and then we would have the migration of the endothelium followed by, number 5, pericyte recruitment, these blue lines. And then we would have an elongation of the new blood vessel. And this blood vessel is not intact, it's very permeable, and it takes a while for these permeable gaps to close, but now we fully have an elongated blood vessel. So let's look from nearby. What do we have here? Okay. we have a blood vessel that sent angiogenic factors to the nearby blood vessel, and the angiogenic factors led to the secretion of nitric oxide, which causes vasodilation in that receiving blood vessel, and the dilation of the blood vessel is followed by permeability and also these vascular endothelial growth factors, PDGFs, platelet-derived growth factor, and Notch signaling pathways would cause the endothelium to start migrating, as seen in green, to make a leading tip. And then a parasite, the parasite layer, the blue layer, would start to detach, and the extracellular matrix will be broken down in order to liberate and free the endothelium. Then we would have elongation and migration of the endothelium towards the leading tip from both directions. And then we would have parasite recruitment. These blue lines, this blue layer of cells will start to be recruited to the site of the making of these new blood vessels. And then we would have a successful elongation of the new blood vessel. This is pretty simple. You see how we start off with two separated blood vessels, and they start to migrate towards each other, and then we would have the elongation, and then after a while we will now have a new blood vessel that was made. Okay, the last thing I would like to leave you with, and that is angiogenesis is actually a pharmaceutical intervention, where now there is, for cancer treatment, we target the process of angiogenesis initiated by the tumor cells to deprive and frustrate the tumor from receiving its source of nutrition, and therefore it can no longer have the proper required nutrition support and oxygen and the proper rate of removal of toxic agents. Another example is when we have macular degeneration. We target angiogenesis to stop the macular cells from sprouting new blood vessels, to end the wet macular degeneration. And in other pharmaceutical interventions, we promote angiogenesis. We try to promote angiogenesis in order to provide blood supply to tissue that is nearly in the phase of becoming ischemic. So angiogenesis is important for healing. Without this angiogenesis, the proliferation would not take place properly. So damage that requires healing must require angiogenesis. And please review what we have talked about in the past, the steps that have led to this angiogenesis, and how we start with a normal cell that undergoes noxious stimuli. That noxious stimuli would lead to cell injury. Cell injury, if it progresses to irreversible cell injury or damage beyond salvage, then we would have inflammation, and then from inflammation we would have macrophages performing the first classical pathway, which is the microbicidal actions of engulfing and phagocytosing the necrotic debris and the microbes that cause the inflammation. And then once they are all removed, the macrophage would shift the course of action from classical pathway, microbicidal actions, the M1 pathway, into the M2 pathway, which is the alternative pathway that promotes the secretion of cytokines that promote healing. And when it comes to healing, we obviously need angiogenesis. Thank you very much. See you in the next video.